All right, we're in our Chapter 4 review today, reviewing for our test tomorrow over Chapter 4. In the first two, really, I guess they count as the first 4 problems on your test tomorrow, you're finding the GCM of numbers and monomials. Remember, we start with the prime factorization of the numbers, and we group our common factors. So we do the prime factorization of 110 and 220. We list our prime factors out. Then what do we do? What do we do now? We group the common factors. And then for each common factor, we multiply it one time in the GCF to get 110. What'd you get for the LCM? Just tell me. 220, because you multiply it by the leftover 2. Now, on the monomial, I like to just do the prime factorization of the numbers, list out my prime factorization of the numbers. For my GCF, what is the only number that they have in common? 2. Now, remember the shortcut I taught you. It's much easier than writing out individually all the letters and then grouping them all together. We just simply look at the monomials, and for the GCF, it's going to be the lower of the 2 variables. So if I'm comparing my A values, which exponent is the lowest? A to the third, so that's the one that goes in my GCF. What about your B? B squared, so that's the one that goes in my GCF. And for LCM, the opposite is true. Well, for the numbers, I still multiply my groups, so in this case, just my 2's, and then I multiply in my leftovers. Times 2, times 3, times 5, times 11. And I get what? 660. And now my rule is, I choose the what? The larger of the 2 exponent values for each variable. So now, what is going to be my A value? A to the 7th and B to the 5th power. Anybody get all 4 of those right? All 4 right? Good. Good. Maybe just miss one. Any questions? Anything? Guys, first 4 questions on your test right there. Okay? So, no surprises. That's exactly what it's going to be. Now, in the next slide, we're simplifying fractions. Here, okay, we learned that we can simplify the number part. I want you to leave your answer improper. Leave your answer improper. You subtract the exponents with a common base and leave the leftovers where the larger exponent is in the fraction. All right, so I want to give you a few minutes to go ahead and work through these 3 problems. All right, so in the first one, we reduce the number part of the fraction. Guys, you can use your calculators. There's no reason not to write this in simplest form. Remember, we still keep it improper. Okay, so we've got 7m to the 4th, n to the 5th over 3. How did I come up with m to the 4th? Anybody want to just briefly explain that, Andrew? Yep. I subtract the exponents of my common variable. I have m to the 5th over m, so 5 minus 1 is 4. My leftovers go where the larger exponent was. All right, same thing goes with the second fraction. 24 over 15 reduces to 8w what? To the 2nd, z to the 6th. I subtract my exponents, and that will be over 5. Now, on the third one, I need to actually multiply 36 times 2 to get 72, w to the 14th power. I add my exponents together over 18w to the 4th power. I know, again, that I subtract my exponents, reduce the numbers to get 4w to the 10th. So now let's go to the next slide. This should, up until this point, you were actually just recently tested over this material, so hopefully it is review. Now, in the next slide, this is a review over section 4.5, where we are finding the product of the quotient, and we're using our product of powers and quotient of powers properties. What does that mean? That means that if I have the same base, I can add my exponents together when I'm multiplying, or I can subtract my exponents if I'm dividing. I want you to go ahead and try to find the product or quotient. Write your answers as exponents for these questions. All right, guys, so I strongly, and let me emphasize, strongly recommend that you write this step on your test tomorrow. Okay, and here's why. Because you can visually see, now when it's all positive exponents, it's not as big of a deal as when we have negative exponents like we will in the next slide. But guys, it's easy to see, okay, here's my common base of 10, and 6 plus 7 is 13, 10 to the 13th. All right, now let's look at the next one. Well, I can multiply my coefficients. Remember, what is a coefficient? It is the number in front of the variable. So I can multiply these coefficients. 5 times 4 is 20. And then I have x to the first power plus 9. X to the first power plus 9, I can clearly see x to the 10th. All right, now, for this step right here, I will not subtract points off of your test grade tomorrow if you don't show that step. However, it could be the difference between getting a right answer and getting a wrong answer. Okay, because if you show that step, you will clearly see what you're adding and subtracting. Okay, so positive and negative. That's important. Now, in the other two, you're dividing. So you need to reduce 24 over 18 to 4/3. And then you're subtracting the numerator minus the denominator, m to the 11th minus 3, which is 4m to the 8th over 3. Now, in the last one, there's nothing to reduce. It's just 7y to the 8th minus 5, so 7y to the 3rd power. Did anybody get all of those right? Okay, very good. Any questions? Questions, guys? Go ahead and pause it. All right, so now let's work on our negative exponents. This is a really big part of your test tomorrow. You have 6 questions on your test that will cover these questions. It says find the product or quotient. So you're still using your product of powers property, same base, add our exponents. Quotient of powers, same base. When we're dividing, we subtract our exponents, except now we have to use our rules for negative numbers, okay? Like I said, 6 questions on your test tomorrow in this section, so it's a big part of your test. So again, it is very important. Will not be counted wrong, but it's important that you show this step right here. 5 to the negative 8th power plus negative 7. What's negative 8 plus negative 7? Negative 15. But you cannot write your answer with a negative exponent, so what do? You put it into the other side of the fraction, 1 over 5 to the 15th. On the next one, we multiply our coefficients. Okay, 2 times 1 is 2. S to the negative 5 plus 3, so it would be s to the negative 2nd power. Which part of this term needs to move? Only the s, because that's the only term that has the negative, 2 over s squared. Now on this one, what's 26 divided by 13? 2. To the negative 4th minus negative 12. You're subtracting what is already a negative in the denominator. Double negative changes to a positive, 2w to the 8th power. Okay, that's one of the tougher ones on your test tomorrow, is that double negative and catching it. Now, on the last one, I simplify the numbers. 5, b to the negative 5th minus 4, b to the negative 9th. Now, which part of my term do I move? B. Only b. 5 is not negative, b is negative. 5 over b to the 9th. All right, last set of problems. You've got 4 on your test tomorrow, scientific notation. 2 of each. 2 in scientific notation and 2 in standard form. All right, let's crank these out. We'll take a couple minutes, and then we will talk about it. Okay, what's going to be our decimal value for the first one? Someone raise your hand and tell me. L'Ariel? 4.62 times 10 to the Aliana. What will be my exponent? to the 7th power. What about my next one? What will it be? Andrew. 1 point. Good. Times 10 to the 5th power. All right, now I'm going the other way. 9.5 times 10 to the class? Negative 4th power. And then 1.06 times 10 to the negative 5th power. Okay, so it's important, guys, that we are counting. Just as a refresher, we start with a decimal here. We count how many places we move it to the new place, and that is going to be our exponent value. All right, just a little review, refresher there. Now, when I'm going the other way, the exponent tells me, okay, if it's positive, I'm making the number bigger. If it's negative, I'm making the number smaller. So the exponent is 4. I'm expanding it by 4 decimal places. Well, if there's already 2 decimal places here, how many zeros do I need to add? 2 more zeros, because I already had 2 decimal places, 41,800. Now, in this one, I've got to have 8 zeros after the decimal. And I keep getting the question, do I have to have the 0 in front of the decimal? The answer is yes. I won't take off for it, but you need to have it there. Okay, so that's a very easy thing to remember to do. Now, 10 to the negative 2nd, so I go left 2 places, 0.0983. And then, how many zeros would I need to add to the last number, 5.617? 3 more zeros. I already have 3 decimal places here, so if I want to go 6 decimal places, I need to add 3 more zeros to give me my answer of 5,617,000. If you understand that, guys, that's everything you need to know for your test tomorrow. You do have one word problem that you should be able to figure out just using your knowledge base that you've built on Chapter 4.